Alright, so let's take a look at geometric sequences as recurrence relations. So again, with the recurrence relation we have a rule. So in this case, the current term I get by doing r times the previous term. Of course, stating my initial term, or I can think of that as to get the next term, I do r times the current term. Either way, to get to the next term, multiply by r and make sure you state your initial term. Now, how this kind of can come up as a question is something like this. So here's a sequence. It says determine the first order recurrence relation for this sequence. It doesn't explicitly say it's geometric, so you would have to figure that out yourself. So looking and seeing, okay, well, what am I multiplying by, or what am I adding by, or perhaps both. Okay, so I'm taking a look. Most of you can probably say, well, r, I take the second term over the first term to get 2. I could take the the third term over the second to get 2, ... So we do determine that we're multiplying by 2. It won't necessarily be this easy. It could be something like a fraction, like 3/4. Okay, so you may need to actually go through that process of doing that division. So I get that my common ratio is 2. Well, my initial term is 1. And to get the current term, I do 2 times the previous term. Okay? Remember in math, we can simply write that as 2 un minus 1, and there's implied multiplication in there. Okay? So we need to state our initial term and our rule. We've done that, so together those two make a recurrence relation. Okay? So that's one where our common ratio is an integer. Now let's take a look at something a little bit different. So I go 48, 12, 3, 3/4. Okay? So the most common answer I would see here is 4, that r is 4. Not quite. If you actually go through the process, r, well, that's u2 over u1, so that's 12 over 48. That's not 4, that's a quarter. Okay? So being really careful here that you do always check. Again, notice my sequence is decreasing, the numbers are getting smaller, so r can't be something bigger than 1, because if I'm multiplying by something bigger than 1, that's increasing. So it needs to be something smaller than 1, so don't fall into that trap. Okay? If I wanted to keep going, I could check as well. Well, 3 over 12 is also a quarter. 3/4 over 3, well, that's 3/4 times 1/3 if we wanted to do division, which is also a quarter. Okay, so whichever way you do it, you get that r is a quarter. So when I come to stating it, it doesn't really matter which notation you use. Our first term is 48. I'm going to write it using the second notation. So I can either write this as a quarter times un, or you can think of it as un over 4. And those notations in mathematics mean the same thing, multiplying by a quarter or dividing by 4. So these are kind of the most elegant. Together, that's our recurrence relation there. Now, our last little thing we can do is, well, I'm not going to tell you what the sequence is, I'm going to make you figure it out. So here it says, here's a formula. Determine the first order recurrence relation for the sequence defined by un, so the term is defined by 0.5 times 2 to the term number. Again, really making note, this is not a recurrence relation, because that's an n, not a un, or un minus 1. Here I'm starting with n equal to 0. So, going back, this is substitution. Okay, so if, sorry, that's not the eraser, that is. Okay. So if I set n equal to 0, I would get u0 is equal to 0.5 times 2 to the 0. If you remember your index laws, anything to the power of 0 is 1, and anything times 1 is itself. So the first term is half, 0.5. If I set n equal to 1, u1 is 0.5 times 2 to the 1. Anything to the power of 1 is itself. Half of 2 is 1 and 2. Okay, taking u2. So I'm just putting the number in where the n currently is. Well, that's half of 4, so that's 2. Let's just do one more for full completeness. u3 is half times 2 to the 3. Well, that's half of 8, which is 4. So my sequence is 0.5, 1, 2, 4, dot, dot, dot. Okay. I could keep going if I didn't already see the pattern, but hopefully by now you're recognizing, well, each time I'm actually just multiplying by 2. Okay. So from this, I've got that my sequence starts at a half, and each time I multiply by 2. So to put that into a recurrence relation, u0, again because it starts at 0 for n, so I need to do it that way. u0 is 0.5, and un is 2 times un minus 1. So there I've got my recurrence relation. So my first term is a half, because when I plugged in 0, I got a half. And to get to the next term, I always multiply by 2, so the current term is the previous term times 2. Okay. So that's the basic idea with common ratios in terms of the types of problems that you can see.